Morning, good afternoon, actually. Good afternoon to everybody. My name is Francesca Piatto from the European Association of Remote Sensing Companies. I would like to welcome you formally to the first user uptake webinar, GHG Emissions from Forest Fire, Advancing on SDGs Indicators Monitoring, Reporting and Accounting. And today it's one of the first user uptake webinar series that we are organizing within the SDGs-EYES project. I wish to go through some guidelines, as I already hear someone in the background. So I would like to ask you to add your full name and surname in Zoom. I would kindly ask you to mute yourself and just unmute you whenever you need to use or to make questions or to introduce yourself. I would like as well to let you know that you're able to turn off or turn on your camera as the webinar is also recorded. What else can I say? We're going to have some breakout rooms as well. So indeed, the name and surname and your organizations are very important for us. And I will also ask you to go on Mentimeter with this code in order to have a bit of interactive session. The agenda of today's webinar is the following. So it's starting now until 4 p.m. It's going to be a very 2 hours dynamic webinar. My name is Francesca Piatto, as I said, and I will be your main host and moderator. And I'm today accompanied by Monica Miguel Lagos from ERSC, as well as our technical moderator, and from Lorin Tertre as our main supporter. We will then move into the pilot presentations and demo sessions from Chiara Quino from CMCC. Then we will delve into some moderated panel discussions with very interesting panelists that are here with us today. This will be a moderated panel with not only the speakers, but also some other community of users present with us. And it will be led by Monica indeed. We will then move into 2 main breakout rooms. As you remember, you already pre-registered to breakout rooms, 1 technical demo and 1 consultant insights. And then we will be moving then to concluding remarks. And again, I kindly ask you to mute yourself if you're not speaking for the moment. Thank you very much. As we are moving on, I would like to indeed have a short interactions with you. Let me know indeed if you see my screen. I would like really to know where are you joining us from. So if you can let us know indeed by connecting, that would be amazing. So you can let me know here where you are connecting. So I see some reactions already. Okay. So again, which organization are you representing us today? As you know, this is a user uptake webinar. So in this way, our main engagement with the community is very important with us. We want to engage with communities, understanding where are they from, who they are, and indeed how they can make use of this webinar. Okay, so I see that we have statistics, which is really good. We have private sector. As we can see, we have university research and trusted entities, super, very good. Forestry Institute, National Statistical Offices. Okay, so this is really good. Thanks. Okay, I see that many responses are coming, so that's good. I think, Monica, for you, is very interesting as well for the technical, for the panel discussions, because again, we have many challenges, we have many communities, and that can definitely make use of the solutions that we're going to showcase later. This is very good. Thank you. Okay, so I will. You can keep going. I will continue my my presentations. Let me know if you. Okay, so I see. Okay, I will stop it here. Thank you. Okay, so So what we're talking about indeed is the SDGs-EYES project. So I will give you a very short description of today's project. The SDGs-EYES is a project that started in 2022, is ending now in end of 2025. And it's a project that brings together research in the industries in order to, in different stakeholder communities, to build a scientific, technological, and user engagement framework for monitoring SDGs-EYES indicator. The main objective of this project is really to boost the usage of SDGs and develop SDG services that can help monitor certain indicators under the SDGs 13, 14, and 15, and under the UN Green Deal. The methodology of this project is indeed starting from a methodology from a scientific technological framework to create and have robust, reliable, and accurate indicators, but aggregating Earth observation data and not only, also space and in situ data. And by this, we are creating the so-called SDGs-EYES prototype service, which as well will gather feedback from end users. And this is where indeed the concept of Earth observation, the concept of, user uptake webinars are really entering the arena, as well with a co-design process that has been put in place since the beginning. And for this, 5 pilots has been created for demonstrations to evaluate and to assess indeed the robustness of this indicator. The pilots that are seen here are actually 5, and today indeed we're going to start with.
Voilà, that's okay.
Sorry, I have someone that is not muted, so if I can ask you to mute himself, that would be great. Thank you. So the main webinar today is focused on the pilot of GHG emissions from fire. And as I was saying, that this is a series of 5 webinars. Each month we will cover each pilot. So next month it will be eutrophication and acidification. So with this, I will give the floor now to my colleague. I will continue with a little bit the purpose of this webinar and expectations, and then I will give the floor to my colleague Chiara. So the purpose of this webinar are really to engage and to demonstrate the methodology to enhance the scientific and technological framework to build robust, reliable, and accurate indicators. But of course, it's also important for us now to showcase as well the SDGs-EYES platform capabilities and how each of the community of users can actually use this platform in order to monitor the different indicators of these 3 SDGs. The purpose of these webinars and to have you here today is really to foster the community engagement and to really try to understand if and assess indeed the capability of this pilot against the needs of the communities. This pilot has already gone through a process of co-design from a technical component, and now that we are indeed positioned now mid-project, we want now to align with user expectations and with user needs. So this is indeed our let's say webinars really focus to gather your feedbacks and your needs, and see indeed how they can also be validated again by you and eventually integrated by the pilots. And indeed, this is not only it's not an isolated approach, but it follows a co-design component, a user uptake component that will then feed the final component, which is the one of exploitation. In fact, also today we will also dig in more into this component of exploitation and how community of users or stakeholders today present could also make use of these piloted services after the project. And as we say, we have different stakeholders. So for us today, also the panel discussions will be a very important tools in order to understand and assess the different needs of all the different stakeholders. I will then move again to another interactions with you in order to then give the floor to my colleague Chiara. Thank you. Okay. I would like also to know, where are you joining the webinar from? Okay, the UK, Germany, Portugal. Okay, thank you. All right. Monica, all of this is also very important. I will share them back to you again, but keep notes for this. Okay, so Paolo.
Thank you.
Francesca, we are not seeing Mentimeter anymore.
Okay, so let me see.
I believe that we are seeing Chiara's presentation.
Oh, sorry, I can close the screen and go back to Mentimeter if you want.
Yes.
Sorry for that. I was too quick.
Problem, no problem.
Thank you, Chiara.
Thank you very much.
Okay, I have stopped sharing, right?
Yes, you've stopped sharing. No, we can still see, I think, your screen. We don't see Francesca's screen. Let me see if I can do this on my end.
Let me know, Lorraine. Thank you.
Yes, I stopped your screen sharing, Chiara. So, Francesca, if you could share your screen again so we see Mentimeter, it would be great.
Okay, perfect. I will.
Thank you.
No problem. Okay. Do you?
We see a background picture. We don't see Mentimeter right now, but...
Okay, let me see it again. Okay.
Yes, perfect.
Okay,
we see
perfect.
It again.
So
Thank
I was
you.
seeing people in any way already replying, which is good. So we have a very good presentations. Okay. And diversification of countries, which is really good. Yeah. Okay, thank you very much. Okay, so I think we are done with my presentations now. I will then ask Chiara now to retake your presentation. Thank you very much, Chiara.
Okay, hi everyone. I hope you can see my screen now, and sorry for that overtaking the presentation before. Okay, so in this session, I'm going to give you an overview of this pilot, which is known within SDGs-EYES as Pilot 1, and this concerns with greenhouse gas emissions from forest fire over Italy. This is our region of interest. Okay, so this pilot focuses on the Sustainable Development Goal 13. In particular, we are looking at the indicator 1310 according to the Eurostat definition, which concerns net greenhouse gas emissions. This indicator is concerned with monitoring the progression towards SDG 13 on climate action. And this is part of the European Commission priorities towards the Green Deal. So why did we choose this indicator? As you probably know, member states are required to report direct GHG emissions from forest fires under the UNFCCC, the United Nations Framework Convention on Climate Change, and the Paris Agreement. And this is part of the national GHG inventories. Wildfires are reported specifically under the LULUCF section, so the land use, change, and forestry. So at the European Union level, at least, this way, the way in which fire emissions are calculated is quite variable between countries. Also, the data is not spatially explicit, which means that when we see the national inventory reports, we have a number just for the entire country, but we cannot connect it with the geographical location of the fire. Then we also have a lag in the production of this data, so it could be up to 2 years. We have uncertainty in the combustion completeness, so in how much of the forest mass is actually burnt, and also in the availability of the combustion material or fuel. So, for example, in the case of Italy, concerning the emissions from carbon dioxide, these are estimated assuming that all the biomass in the burned area is completely lost. Although this is not necessarily true. Sorry for that. As we know that some of the biomass remains in the field or decay in a second stage. And this is quite a conservative approach. So what we want to do, we would like to find a more realistic measurement, more accurate measurement of the proportion of biomass lost during combustion. We use the IPCC methodology that I'm going to introduce in a few slides. And also, we, according to to what Francesca said in the general presentation, we would like to use remote sensing data from Copernicus service to increase the timeliness, the accuracy, and also to make this methodology scalable to other countries. So initially, the pilot was developed for the province of Cosenza in Calabria. On the map on the left is that small region in red. This region was chosen because it's quite prone to forest fires. But given the fact that we use this methodology with georeference data and remote sensing data, we could extend these results all over Italy, which is also the reason why this methodology could be scaled beyond Italy as well. So the outcome of this project is mainly a tool producing maps for this SDG indicator for Italy, which has the potential, as I said, to be extended to other countries in the European Union. These maps are available to an SDGs-EYES platform. This allows geospatial analysis by the users and also to output data that can be integrated into the national inventories. And again, as Francesca mentioned before, an important part of this project is the co-design with the stakeholders. So we have a two-way feedback process throughout the entire project, which inform the research that we do. As you can see in the image, we had a workshop in June at the ISTAT office, which is the National Statistical Office in Italy. Here we presented the first results of the pilot, and we received in turn very important feedback from the stakeholders. So for this project, our main stakeholders are the Italian State Forestry Corps, which are in charge of dealing with the fire in the field, but also on collecting post-fire data. For example, the burn area that we use for calibrating the remote sensing data sets and other types of in situ data. Also, we had ISPRA, which is the Italian Institute for Environmental Protection and Research. They are in charge of delivering the national greenhouse gas inventory report. Sorry, there is a microphone open. And we also had the University of Sassari in Sardinia that focuses also on studying forest fires. And we also have validation users. So the ECMWF, we have 2 members from the ECMWF in the panel later that you will meet. And also the users that I mentioned before helped us, are in the process of helping us with the validation. So I just want to show you quickly the first outcome from a questionnaire that we submitted to the users at the very beginning of the project, just to show you that the issues that they highlighted were actually integrated and are now an important part of the development of the project. So the first point that was highlighted was the improvement for this project of the temporal and spatial scale of the greenhouse gas inventories. Then they also highlighted the need to detect small burn areas. Now, this is a crucial problem for satellite-based products that have medium resolution. So a number of small fires go undetected. Also, they asked us to look at this common implementation for the European countries, what I was mentioning before. And another point is the use of land use category definition to be taken into account so that we can disaggregate emissions and removals by specific land use category. So we took account of these points, as I will show you in the methodology soon. The one that is not fully integrated, but was part of a different strand of research that we published in the proceedings of the EGAS conference last year, was the detection of small forest fires. So we used high resolution data from the Copernicus Sentinel-1 and Sentinel-2 satellites to detect 2 small fires in Sardinia that were measured by the Forestry Corps, but didn't appear in the satellite data products that we are using for looking at the barn area. And we were able to detect them. Now, this part is not fully integrated in the platform, but could be a future step of improvement. Also, as I will mention later, now from 2018, the EFIS, which is the European Fire Information System, has integrated the Sentinel-2 data. So the high resolution data should be already there for 2018 onwards. So to summarize our objectives, what we aim to do was to provide an intuitive and robust mapping tool for national statistical offices and policymakers. Also to design a workflow that is replicable and scalable based on Earth observation data. Increase the temporal resolution and reduce the timeliness of the release of the data. Improve the spatial scale of the measurements and provide the geographically explicit data. But also we would like to improve the current methodology on how forest fire emissions are calculated and improve the accuracies of the measurements. So how did we estimate greenhouse gas emissions? We used this quite simple equation from the IPCC. This is the extended formula for both CO2 and non-CO2 gases that are directly, so immediately releases from fires. And we have that the parameters for this equation are the A, which is the barn area, so the perimeter that is measured often on the field, B, which is the mass of the available fuel, so the mass in this case of the forest. C is the fraction of the combusted biomass, so what we have lost in the combustion process. And then we have the emission factors, which are related to each different GHG. So for what we are doing is to parameterize this equation and to try to make it as scalable and as dependent on Earth observation data as possible. So for A, which is the total forest surface affected by the fire, we use, as I mentioned before, EFIS, which is the European Forest Fire Information System. From EFIS, we have data from 2000 to up to date. And as I said, like the minimum detection unit was less than 30 hectares for data before 2018. Then for the biomass, this is the total pre-disturbance, so pre-fire biomass. It could include the surface and also ground material. So for this, we use the Corinne-Lancover map, the 4-level developed for Italy. The year reference is 2018, and we just consider forest classes. But we cross-link these classes with national forest inventory data to get the carbon pools that were measured in the field, in this case by the Italian National Forest Survey in 2015. And Corinne-Lancover comes also from a Copernicus dataset from the Land Monitoring Service. So the combustion factor represents the most tricky parameter in this model. And this is, as I said, the amount of mass that is actually lost during the combustion. So this parameter is also known as binding efficiency, and it traditionally is assumed to be constant. So it's always the same for different types of vegetation, temperate, tropical, savanna. So the IPCC provides a single value. However, we know that the reality on the ground is much more complex. And so the idea has been to connect the combustion factor to fire severity. So fire severity is a measure of the impact of the fire on the vegetation and the soil. And luckily, we have actually a product from EFIS. Maybe I didn't mention this before, sorry, but all these products are free of charge. They are available from Copernicus and everyone can download them. So there are layers from EFIS about fire severity from 2018, which is the year that the Sentinel-2 has been integrated, to nowadays. So I think the last one is 2023, 2024 should be come up soon. And in this way, we are able to know different classes of severity from very low to very high and to connect them to the amount of biomass that is lost. Finally, we have the emission factor, which thanks to our collaboration with TSMWF, we were able to update from the values from the IPCC in 2006. We use the NEVA database, which combines data from global laboratory and field studies and is more updated than the data from IPCC 2006. So in terms of some results that we'll show you, this comes from our platform. I will give you a quick demo soon. But one of the main results is the resolution that we can have at the fire level. So we can see the single fire events, and we can look at information by fire events, not simply at the national scale. Also, thanks to the fact that our product is spatially explicit, we can also look at different regions, both administrative regions, so for example, the Italian regions that you see on the right, up to the actual municipalities, so very fine administrative level. But also we can look at the ecological level, so we can see how emissions are stratified by biomes or by ecoregions. And this kind of information can support, for example, fire management strategies by knowing where fires happen and which ecosystems are most susceptible to fires over time. And indeed, we can build a time series data where we can have the emissions. This is the total emissions, but we can also do it by single components, so the single gases, by land cover type. Just to mention the point by the user feedback workshop, where it was also important to see this kind of information divided by different forest types. So just a note on the burning efficiency or the combustion factor, which I mentioned as quite a tricky parameter. So ISPRA, which is the agency in Italy that is in charge of the national greenhouse gas inventory, the way they calculate emissions from non-CO2 gases is to use something called scorch height, which is the height where the height of the flame reach during a combustion event. This information is taken in the field in Italy by the Forestry Corps. However, sometimes this data is missing. It's not always taken during the surveys, and then ISPRA uses a gap filling procedure based on the mean value for region and forest type in that area. So after we had a workshop where the Forestry Corps were present, we realized that in order to make this methodology scalable, we needed a parameter that was shared across different countries as well, because not everywhere scorch height is collected. So we decided to develop our own model of combustion efficiency. I'm not going to elaborate on this a lot. This is going to be part of the paper that we are publishing soon. But we have done that for Italy by collecting data on the biomass lost during fires collected in the field and relating that to remote sensing parameters on fire severity. So from this, we could get our own combustion factor. And finally, this is just a quick demo of the platform. I'm just going to unshare the presentation for a moment. Okay, so I hope you can see the screen with the platform, right?
Yes, we can, Chiara.
Okay, I already selected some data just to speed up the presentation, but basically it's quite an intuitive user interface. You can select the year. Here we have from 2018 onwards because of the fire severity layer from EFIS being available from then. Then you are able to select the different Italian regions, but you can also go down to provinces or municipalities. So if I had to select a municipal, yes, you can see all the list here. So when you calculate the emissions, you will get eventually a map showing the location of all the fires. And if you zoom on single fire events, you can see some information about the type of forest, how much area was burned in this area, total emissions, but also a breakdown by the main pollutants. And you can click on the map. At the moment, you see the breakdown of the different forest classes. So, for example, the Mediterranean oak forest, deciduous oak forest, and so on. However, an improvement we are going to implement soon, also thanks to the feedback from the validation users, is to have the time series. So we will be able to see not just 2021, but also the entire data set over the years. And you can also download the data. When you click here, you can download it. You get a zip file with the plots and the CSV files with so tables that will have the emissions broken down by administrative area. Okay, so I think this is the entire presentation from my side. So thanks for listening. And if you have questions, please feel free to ask.
Thank you very much, Chiara. Very, very interesting. And I will ask again some of your time to have some quick reaction to Chiara's presentations by going back to Mentimeter, because I have 3 questions for you. And at the same time, I would also make sure to reiterate again, as my colleague Lorena already did in the chat, is that indeed this methodology presented by Chiara is will be soon published. It's not yet, so to please keep in mind not to disseminate for internal or external purposes, and to respect the intellectual property of this tool now. And of course, in the future, this will be shared, and you will be able to use it, of course. So thank you very much. So who do you think indeed is the beneficiary of this pilot? So the majority is regulatory government, other, okay. Anyone else? Okay, agencies. Thank you. Okay, indeed the majority, it's regulatory government. That's so good. Chiara, also if you want to comment upon this, since it's your it's your pilot, but indeed I think that these initial answers that you are receiving are sort of well connecting to what we've been discussed so far. Okay, then I will be moving to the next one. Indeed, instead about what are the expectations from your webinar. As you know, for us, the main message that we want to pass is indeed gather the communities, understanding your needs against the pilots, how they match any that could be also potential test validation users again of this pilot, and eventually becoming an exploitation user in the future, but also could also just be, from a technical component, discover the technical knowledge and tools for implementing the services. Okay, so I'm seeing that we are getting some different questions. Okay. Yeah. Okay, so we're almost identify best practice for replicability service in other contexts. This is really good about replicability, absolutely. Okay, I think I still have another question. Yes, indeed, which is indeed if this tool would be useful eventually for your organizations. Okay, I mean, we will represent these questions after in any case, so we will be able to address it more in discussion, more in details as well. Okay. Well, thank you very much, Chiara, again for your presentations. I will stop here the Mentimeter, and I will give the floor now to my colleague Monica. Monica is going to be our technical moderator for the moderated panel discussion. And yes. Monica, I will give you the floor.
Yes, thank you very much. Thank you very much for the handover. So we move now to this discussion with the stakeholders, which you have seen the work done until this methodology, also done by this interaction of different communities. So CMCC somehow is representing the research community, but in this panel now we will try to have the representatives from the statistical offices. We will also have representatives from a country, and then we will have also on board the entrusted entity like INCIENT as a validation user and also provider of this Copernicus data, which already Chiara mentioned about the free and open data policy behind. And then finally, we also see the very important role of the commercial sector, which is normally passing from the research to operationalization. We have Fabio Bacchini from ISTAT. Maybe the panelists could start open the cameras. Is the Italian National Institute, and normally in their perspective, he will share the insights into their integration of Earth observation into the national reporting frameworks. From the perspective of the country, we have Paolo Canaveira from the Technological Institute of Portugal from the University of Lisbon, and he's responsible in the country from the LULUCF sector from the greenhouse gas inventories from Portugal. So he has a back experience on the reporting processes and the challenges. And from him, we also expect maybe this wishing list that we'll try to work on in the next months. Then we will have Mark Parrington and Ernst & Coffey, both from the European Centre for Medium Range and Weather Forecast, so ECNWF, and both are involved in the Copernicus atmospheric monitoring services, and they will provide the perspectives also from the entrusted entity, but looking into the leveraging the Earth observation data from monitoring wildfire emissions and improving atmospheric composition models. And then we have Natalie Morin from GeoBill, representing the private sector. They are doing a lot of innovation also on this field. So they are looking into the near real-time data delivery for forest fires emissions and how they collaborate with the different stakeholders. With that, as the idea is that we are presenting now this methodology, but as has been said, we have been processing this co-design approach with validation users, and now we try to develop a little bit further from the user update perspective, to pass a little bit more thoughts and bilateral discussions about potential exploitation. So the role of this panel is very open. There will be open questions, and we will try to have the feedback from these organizations that are key stakeholders. So I will ask a question for all of you from the panelists, and then maybe at the end, I will call a couple of people from the audience to complement the views from the people presented. So from your, the questions will be about from your perspective institutions, what challenges and opportunities do you identify to monitor these tools into your own methods? So looking into Fabio, Fabio is is from the ISTAT, from the Italian National Institute for Statistics. He's an economist, and he's the head of research at ISTAT, temporarily appointed by the Italian Court of Auditors. He's also in charge of, has been in charge in different macroeconomic analysis and sustainability. So he has a lot of experience already in European projects, international projects with Eurostat and European Commission. So Fabio, it's a very generic question, but the idea is that you describe from the statistical community perspective the challenges and opportunities that you identify using Earth observation, satellite-derived data into enhancing the timeliness and accuracy from greenhouse gas emissions.
Good morning to all. Thank you for inviting me to this seminar. And as you know, I tried to follow this project from the beginning, so it means more or less 2 years or more. And I tried, as you said, I tried to fix what is the expectation, at least from National Statistics Institute point of view. So to fix this point, I would like to share just two picture. I think I'm not able to share. I don't know if you can allow me to share my screen.
Yes, I will allow you, Fabio. I will do it now.
Thank you. Okay, thank you so much.
Just in the interest of time, that will be just a showing image, so we will not develop a lot on the work. Yeah.
No, I just two pictures related. Just to say what are the main points. So this is the OECD website, and you can see that there is one of the several dashboards that we have now, both in the international organization as well as in the National Statistics Institute. And this is the dashboard related to climate action, because as you can imagine, climate action indicators are extremely important. What is one of the points that also Monica stressed out before is the timeliness of the data. So you can see here that we are up more or less to 2022. This is the latest data that we have now from the statistical point of view concerning the GHG emission. And I'll try to stress the other point from a statistical point of view. If you go on, this is the Eurostat website, the data repository for Eurostat. And you can see even here that the latest data available, this is the dashboard right now, is exactly on 2022. So the first point from statistical point of view, and the first expectation is that we can try to gain some months or even years in the availability of the data on the emission. This is the first point. The second point is concerning the granularity about the data available, because as you have seen in the presentation of the platform, basically we were able to see one region for Italy, Sicily, but much more than that, we are able to see just one fire inside the region. And this is not the case on the present data on emission, because I'm not able, both at the Eurostat level, but even at the Italian level, this is the emission, sorry, because this one is in Italian, but this is our dashboard on SDGs indicators. And as you can see here, basically the latest data is year 2023, so it means that at least in Italy we gain 1 year compared to the other countries. But you can see that we are not able to have some disaggregation, some granularity, not more than the main territorial area. So it means now South Italy and so on. So just to close my point, my first speaking, I would like to stress again that basically we can use this project, we can use satellite data to improve our statistical indicators in two directions. The first one is on timeliness for the indicator related to the emissions, and the second one is on granularity. If at the end of the project we are able to follow the pattern that Francesca, Chiara has presented before, I think that we can, the project will be useful to all the statistical community. So thanks again.
Thank you very much, Fabio. It's excellent because you give us two keywords: timeless disaggregation and this granularity. So these are really points that we need to work forward. We do have in the audience people on the statistical community. Maybe through the breakout sessions we could comment a little bit more on this. The breakout sessions are for that purpose. So now we have also the perspective from a country, Italy, on the national statistical part, but we have also on board another country, but a little bit more on the emission reporting. So I would like to invite Paulo Canaveira on board to this country perspective, his experience about this reporting. He's a forester by training and specialized on climate change policy from the development and implementation itself. So he has been participating in many negotiations about climate related in the UNFCCC and also at the EU level. So we have a great experience having Paulo on board. So Paulo, a little bit as a generic question is the same. It's really to look into challenges, opportunities using satellite-derived data, Earth observations, and how complementing these satellite and in situ. So for the methodologies, and how is your experience in Portugal? Thank you.
Thank you, and good afternoon, everyone. And thank you for the opportunity also to tell you a little bit about our experience. So we have been using for a number of years already some Earth observation data. We produce annually a burnt area map, but it's a 0-1 kind of map, so it's just burnt and not burnt. But we have that for every year for at least 20 years now. Of course, the satellites have been changing over time. Now using Copernicus, but before it was Landsat and so on. But the end product is a similar one. We then convert, or we then need, of course, to know what type of land use is burning. So we do that not directly with this product, but by crossing that product with our, we have a national map of land use and land use change. And so we can, by crossing these two products, we know what type of land use is burning every year. That is the part of areas. And of course, as you shown, as Chiara showed in the presentation, this is just part of the problem. We then need, of course, biomass data that is coming from the National Forest Inventory. For now, we are using 8 different forest classes, but then we use an average value for the whole country. And this is one of the limitations of the exercise that we are doing, because let's say 1 hectare of maritime pine will burn the same anywhere in the country, and we know that's really not the case. On the combustion factor, we are using a slightly more sophisticated, I guess, approach than the one that you presented before, because we don't look at total biomass, but we look at leaf and small branches biomass, and we have combustion factors for different types of biomass. This is because, of course, not all types of biomass burn equally. And so we have this approach where we look at combustion factors per component of biomass rather than one combustion factor for everything. So this is how we do it. Where I see opportunities for improvement is in these later aspects. For one, we know that carbon density is not the same in all the places. So if you have an old forest burning is not the same as having a young forest burning, even if they are from the same species. So right now we report that as being the same, and it would be nice in the future to not only knowing what land use is burning, but what is the biomass density of that location, so that we can have higher emissions where the forest has more biomass and lower emissions where it has less. And the other aspect that changes is that the combustion factors are not independent from, of course, from the fire intensity. And it's not the same to have a fire now or to have a fire in mid-August when everything is dry and hot. And so to have this differentiation also in combustion factors, that would mean that when you have a lighter fire, you would have lower combustion factors, and when you have very hard conditions, you would have higher emission factors. So that would be, I think, ways to improve the work that we are doing. I don't know if you want to have questions or.
I think we will encourage the questions for the audience to write it in the chat, and maybe at the end we could still summarize and highlight the people to take the floor. So thank you very much, Paulo. I think the opportunity for improvement, I think, is in a good place in the sense that different stakeholders could work and collaborate together. So let's exchange. This is the opportunity to do, and we still have this year ahead to go and try to see how we could better connect the things. Specifically in the topic of the combustion factor, as you said. So let me now bring on board Mark and Ernst, both from the European Center for Medium Range Weather Forecast. Ernst is a senior scientific that joined the CAMS team at ECNWS to work in the modeling of greenhouse gases. He has 30 years of experience working in meteorology and climate fields, and he has a big experience also in the research and other institutions. While Mark, also in the same institution, he has a PhD in atmospheric physics, more than 25 years of experience, and their specialty their expertise are on the application of Earth observation data in situ measurements, numerical modeling, data simulation, etc. So we have on board really experts on the scientific component. So maybe because you are both in the same institution, so just let us know. Maybe one of you could reply on this one. Maybe I know that Ernst is a little bit more generic than Mark, will be more in the dimension of fires, emissions, but in the GHG greenhouse gas emissions monitoring and emissions, Ernst, maybe the question is for you. What challenges and opportunities do you see integrating the Copernicus services that you are producing also for this reporting from the entrusted entity perspective? Yes, Ernst, I think you are on mute.
Yes, first I would like to say something about what we are doing. There are two things. In CAMS, which concern the greenhouse gases, we are using emission inventory from the national inventory, and then within CAMS, for Europe, for instance, there is a regional product where we try to refine this product. And as I said, we have this data where we have 2 years behind. Then to make a forecast, we need to extrapolate this data in near real time or in time by using the trend of the data before. Then we use this data, for instance, for the forecast or the concentration with the data considering the anthropogenic emissions, then the sources, also the sink that come from the natural emissions. And all these emissions, we are considering them, and then we transport in the model to have a concentration somewhere, and we predict that. Just to know that for the GHG, the fire emissions is about, if I consider, for instance, for CO2, it's about 5% if you consider the total emission globally. It's not so much, but depend on the year, depend on the local, where you have it. You can have a large fire somewhere, and then this can be very large. For CO2, it's about 5 and 10%, something like this. Then this is the way you are using this data now. And for the fire, we are using what we call a global fire emissions, which is based on the fire radiative power, which give an idea of the dry matter. And from this dry matter, considering the biome, you have the emission factor, and then we compute the fire emissions. And we are using it in our model because our model is global. This is the first thing we are doing. There are another thing which is very interesting for us. We are developing one tools which consists to use the concentration from the atmosphere, from the measurement from the atmosphere that concern the satellite, the total column, and then using this data and saying, okay, normally what we have in the atmosphere is something which have been emitted from the ground, and then to come back to infer the emission from the ground, which we call inverse modeling. In this case, for instance, refining the data at country levels by doing the work has been done, meaning that we have different products we are compared. We can have an idea about the uncertainties on this data, and this kind of uncertainty we can use in this system. That's the thing we are following up. I can talk more and more, but I think
yeah, thank you, Ernst. The topic of uncertainties, I think, is really, really important. And in fact, there are several groups that are working on this because we will have these breakout sessions. Also, that could be a topic related to elaborate further. But let me also ask Mark to take the floor, because I noticed that Mark has also a comment, a different perspective that maybe on the provision, I mean, on the comments from the statistical, how the statistical office is doing. So Mark, take the floor.
Yeah, thanks. Yeah, thanks for inviting me to take part in this event today. So yeah, I think just based on what Fabio said and what Paolo said, just maybe the perspective of what we aim to get out of the work that Chiara has done in terms of the fire emission estimation. So we are able to provide somewhat near real-time information on fire emissions. But we have various constraints because we're doing this in an operational framework, and the goal of the fire emission estimation that we're doing is to be able to initialize or have the best emissions information for our air quality forecasting at the global scale. And that means we're making a lot of assumptions, and some of these assumptions are quite crude and not updated all that often, such as the type, the vegetation type, the vegetation maps. These are quite coarse. We're not even looking at, we have maybe 8 vegetation classes, which are applied globally. And also we're running at sort of coarse resolution. We're based on these satellite observations of fire radiative power, as Ernest said. Most of those observations are coming from low Earth orbiting satellites up to now, although we will move to geostationary. And this is a further limitation on detecting fires below the detection threshold, but also detecting fires that are burning out away at times other than the satellite overpasses. So we're very much biased to the fires that are burning in the early afternoon period and in the mid-morning. And I think one of the key things that we can learn from and maybe look to improve the way we do this from the work that Chiara's done is in having that information at the final scale. One of the other challenges, which I forgot to mention just now, is the validation of the kind of fire emissions data that we provide. And the work that Chiara's done is showing that you can get see smaller fires at the national, at municipality level almost. This obviously will scale up and would be a valuable data set for validating then the fire emissions data that we provide. And that's not just true for our product. There are other fire emissions products which are global, and they all suffer from similar issues and limitations. And in the wider atmospheric chemistry community, wildfire science community, there's a lot of activity to better understand the uncertainties that go into the biomass burning emission estimation. And this is work that would, when applied to other countries, potentially will be an invaluable data set for validating those emissions and leading to improved air quality forecasting, improved understanding of the emissions profiles depending on the type of fire and what's burning, like along the lines of what Paolo was mentioning. This is all some way into the future, but I think there's certainly the steps that across the scientific community need to be taken to better understand uncertainties in fire emissions and how that feeds to air quality and climate for modeling as well.
Okay. Good. So we have now the perspective from Ners and Mark covering a little bit the trusted entity and also the willingness to discuss the topics on uncertainty, the topics on biomass burning, the emissions dynamics. And so it has the impression that there is really a good floor to discuss with entrusted entities to see the evolution of the Copernicus services. So I guess that we could recap this maybe in the breakout session. I mean, how we could collaborate with the entrusted entity to inject case stories or the innovation that the companies or institutions or academia are doing in this field. So let me go now to Natalie. Natalie Morin from GeoVille is representing the private sector. So Natalie is a senior project manager. She's specialized in forestry, land cover, land use, and risk mapping at national and international levels. She has more than 18 years working at her experience, but she was working in public domain, in academic research, and now moving to the private sector. So with her expertise, she really knows the EO value chain from the data acquisition to the delivery of high quality end user geospatial products. So she also has experience into all this reporting on the land use chains and forestry. So Natalie, we have you on board. Thank you very much for joining us. So also it's a little bit the same question from the data provider. I mean, what challenges you are seeing and also to enhance and opportunities in the work that the private sector is doing to enhance the use of satellite derived data and specifically increasing this accuracy and timeliness into your products and the experience that you have also interacting with the public sector. Thank you.
Thank you, Monica. Hello, everyone. Thank you, Urs, also for the invitation to this panel discussion. So I'm representing GeoVille, based in Austria, which is one of the main EO service provider for the Copernicus land monitoring service. We also have, in recent years, some activities, R&D activities in the field of LULUCF, greenhouse gas reporting. And notably, there was the BRIEF project, we just ended last year, which scope was to develop a proof of concept of a prototype, EO integrated prototype, for monitoring, reporting, and verification of greenhouse gas emission and removal from above ground biomass changes in Austria and wildfires in Turkey. So similar endeavor than what has been presented within SDGs-EYES. I think it's very interesting maybe to have afterwards also some discussion, more technical discussion, but what I can say to answer the question, maybe I can also say what we've done. There were several block units in the end, we developed a fire emission model, but it's based on a Sentinel-2 time series Sentinel-2 analysis, forest disturbance, also biomass, above ground biomass mapping, using a tool from commonly developed by NASA, the GDI team, and ESA. I see that Stefano from Sistema is also in the audience, so he might also want to comment. So AGB maps from 2019, availability of JDI onwards, the harmonized Landsat Sentinel datasets, Sentinel-1, and cup them and adjusted algorithm with above ground biomass maps, wall-to-wall maps over Turkey at 30-meter resolution. And we also had the emission also based on the IPCC equation that was presented in SDGs-EYES, but some improvements were made here with a fire delineation and severity model linking the combustion factor to the degree of severity. So there are some, we have our own biomass maps and also improve combustion factor. We use FIS more as a validation of the fire delineation. In the end, I don't want to go too much into technical details, but to answer specifically your question, challenges and opportunity, I see as the main challenge was the availability of ground truth reference data. especially for biomass and also for biomass changes, because this algorithm, which I think is at the moment one of the most powerful tool, needs calibration and validation reference data. So basically biomass sample plots from national forest inventories, and also a fire database. And for Turkey, we could only get, so this project in Turkey was developed in very close collaboration with the Turkish National Inventory Compiler for LULUCF, so the General Directorate of Forestry, and they could provide, the Regional Directorate of Forestry of Istanbul could provide some data sets. So we have a quite, I think, interesting map over the Istanbul region, but to scale up this method, we really need the calibration data. So that's the main challenge. And as far as opportunities, of course, we provide a wall-to-wall map of forest fire and emissions, which can then be used as a comparison tool for verification purposes by the or directly integrated in the LULUCF inventory. So Turkey, they also confirmed that they will use the output of BREATHE as at least for verification of the report for this year's submission. And also this complies with the new revision of the LULUCF regulation on geospatially explicit data, on reporting on the tier 3 for key categories like forests. This is a model that's scalable, also to other countries, or I would say Mediterranean basin countries. And finally, also could be used for the secondary voluntary carbon market. So not only the LULUCF compliance market. So I think that would be from my side. If you want any further information, you can contact me.
Thank you, Natalie. I think well, first is just to thank you also to give another perspective of another work, and also be willing to discuss further on a technical perspectives also with the development of this. The question on in situ data, the calibration validation is very important, and I think Chiara also addressed that. It is maybe back to the national, I mean, maybe the experience that maybe Paulo could have here, because you are maybe more engaged with calibration and validation of data sets. Maybe then I will go for Fabio to see her perspective, but from the perspective of the representative compiling this reporting, Paulo, could you tell me more about this integration and calibration and the difficulties to get this data?
Could you elaborate a little bit your question on what do you mean by calibration? If we do any exercise of trying to...
Yeah, if from your experience, did you have also these issues of finding the in situ data to calibrate the satellite data, so for the models and the exercise that you are doing?
Okay, so we are not using biomass data from satellites. So we are, for now, the use of satellites is it's basically on determining the area that burns every year. So it's a very simple use. And as I said, the map that we get from there is just burn, not burnt. And then we cross that with a land use map. For biomass, we are using as a totally independent set, if you like, the National Forest Inventory. So and that we are using, and in that respect, we are using national averages that come out from the in situ sampling that is done there. It would be nice to have these things integrated, of course, either having more spatial density in the information coming from the NFI, which right now, if you want to go in at, let's say, municipality level or something, then the information that we get from the National Forest Inventory is, of course, too coarse for that type of interpretation. So yeah, I see a huge potential in this tools that would allow us to cross between biomass density and different land uses. My understanding, and I'm not in that community, so I might be wrong, but my understanding is that these biomass products still have a huge uncertainty around them. So there might be a need to develop some, I don't know, hybrid approaches where we try to use the satellite information combined with the ground information and see. So yes, I would say this calibration is usually needed. I would be reluctant in trusting one of those products immediately without being further persuaded that this calibration is already at an accurate level. So yeah.
Okay, so there is a room for working on this perspectives, also maybe from both sides, no, from the SDGs-EYES project itself, but also maybe Nathalie, also you reinforce this issue. So maybe something that the community should be more open to discuss this getting the data from in situ and how we could calibrate and validate. Sometimes this is really a closed door for having that. So let me go back to Fabio, and you mentioned before about the importance to increase the spatial or temporal resolution. How then will be, if these things are happening in the right direction, how difficult will be for the statistical office to implement that into the hierarchy, that you will assume this model, this methodology is good, is validated. So how will you take this on board? Any other, how long that will take, how easy is going to be that you will systematically use it?
Cool. Thanks. This is a huge question. I mean, the answer is not easy. I just would like, now that I have the power to share the screen, I'll try to do again, just to, because your question is, seems to me, related. This is the previous project that that is called the Maxwell, making well-being, sustainability and well-being working for policy analysis. And I think that we are in this situation here on which the satellite data can useful in this area, because now there is a very huge discussion in the statistical agency institute on the idea of big data, and we can consider satellite data in the set of big data. So the idea is that what is the gain by using different sources, and what is the cost that we have to face on when we change the source. So basically, you can see from this graph that the comparison will be always among the traditional sources, and you can see here, this is the census data, and you can see that this is the old generation of data, the oldest generation of data, and you can see that the cost will increase when we try to gain for granularity. For example, now in Italy, we haven't the census anymore, but we have an early census by using different sources, someone that are administrative. So basically, we have at least three waves: survey data, administrative data, and we have now the big data. Inside this framework, we have just to gain about the idea in which we can try to design the steps on which the satellite data can enter in the process. One important thing is you mentioned about calibration. So it means that you are thinking about one data that is reliable for all. And I can say that one important thing inside the institution is that you can replicate this data each month, each year, because other ways, I mean, it's just one shot, and statistics is against one shot, only for some specific goal, such as the COVID or something like that. But otherwise, we are searching for something that is replicable and we can use it inside our process, and it should be strongly related to other sources and to the production phase. So I'm searching for some indicator that is related to a new process that can produce some gain in terms of costs. So, I mean, satellite data are not free, and you have to pay both for the data as well as for the elaboration of this kind of data and for calibration, as you mentioned. And then we have to make some discussion and to go deeply in this trade-off between the gaining information. As I said, the granularity seems to me one of the most important gain, and the cost that we have to suffer for picking up this gain. Thank you.
Yeah, thank you very much, Fabio. I think you're giving keywords about the flexibility advantages. No, you are talking about the gain, what you are getting out of this, what is balanced on the coast. So I take the opportunity that we have also on board another statistical office, but in this case is from the UK. And I would like to take the floor. If Taide is Sousa, maybe you could take the floor. The question will be a little bit from your experience. I mean, the idea is about the main challenges you have, because probably you are not developing this methodology using satellite data, but maybe which are the challenges from the UK statistical offices you are facing with this potential reporting?
Yeah, thank you. Yeah, so my name's Ty D'Souza. I'm from the Office for National Statistics in the UK. Currently, our challenges are capacity and resources. So the upskilling in Earth observation, data processing, analysis, and having that foundational knowledge, which can be quite specialized. So that's one of our main limitations at the moment in not implementing satellite data into our official statistics. There's also the computational resources that it requires. So yeah, so balancing the benefits. Yeah, we're trying to work out if there's benefits, added benefits to using it, and using the resources to change or create new methodologies to have productionized outputs. So as Fabio was saying, each month, each year, and having that consistency, that's really important. So yeah, we are very interested in hearing about the challenges and that other CISC officers face.
Okay, thank you very much, Tide. And in fact, as you said, you are supporting the Fabio's views on this. You need to understand really the gain on this, the feasibility advantage. So we will keep working on board on this, and we hope that we continue the discussion. So let me get back to Ernst and also Mark. A little bit more specific here about the question will be for Mark about how the Copernicus Atmospheric Monitoring Service is filtering emissions by the vegetation or by vegetation or land cover type. So a little bit more into the detail that you are providing as CAMS, but also to triggering the people to go to the breakout session to discuss a little bit more on this topic if it's interested. So Mark or Ernst, yeah.
Yeah, I think it relates a little bit to what I mentioned earlier. The way we're estimating emissions, of course, remember this globally in an operational setting, is we have this very coarse definition of vegetation types to cover the globe, and so we're a little bit limited in that in the estimations we provide. However, we also provide the input satellite measurements which go into estimating emissions. So the fire radiated power we have as a gridded parameter. This is based on 2 MODIS instruments, and in principle that data can be taken and then any kind of vegetation map could be used, or land cover map could be used. You can change potentially the emission factors, which Chiara has done. So there is a lot of flexibility in being able to apply the kind of data that we have to re-estimate emissions for different land cover types at different scales. and emissions factors, but it's not something that we provide operationally currently. We're sort of limited in that respect. But in principle, everything is possible.
Okay, thank you. And from Ernst, maybe from the GHG monitoring on emissions perspective, do you want to complement something, or Mark, with the same question? You're on mute, Ernst.
Yeah, just to give you I start to talk about it. Within Copernicus, we are developing a system which we call inverse modeling system, which it's based on the observations. As I said recently, we have the concentration from the atmosphere, and then we try to go back to see how the emissions are, which we call inverse modeling. And doing so, we can optimize different type of emission that can be fire, can be different sector of anthropogenic emission, can be the source from the vegetation, if I consider the CO2. And this kind of product, even if it's not global, at European level, if we can improve it, as I also said, in this kind of system, we need to ascribe the uncertainties on the product we have. This will be very interesting for us. Something I can add, yeah.
Okay, thank you very much, Ernst. So let's try to move now to the to Paulo, and maybe because we discussed a little bit about you may have a wish list on the expectations. Could you let me know in which direction they are, or for this concrete topic? No, obviously, but and from the perspective from your government, your country, which will be this wish list to improve these methodologies?
From our starting point, where we already have the methodology implemented that is geographically explicit and so on. So our perspective is, how can we improve the per hectare estimates that we are doing? So I think we have reasonable numbers at national level, but if you want to downscale and start having decent numbers at local level, then we need more granularity in the information that we are using. That could come from, and I mentioned that in my initial presentation, my initial intervention, that could come from two improvements compared to what we're doing now. One is to have this combustion factor associated with fire intensity, so making not all fires be the same in terms of combustion factors, how much biomass is lost during the fire. And the other one is, and that was mentioned already by others as well, is this idea of biomass density maps, where we would differentiate between forests, the emissions coming from forests that have more biomass and vegetation that has less biomass, so that we are not using a single emission factor for everything. So the emission factor would actually become a combination of this local level biomass and the local level fire intensity, rather than using average or default values for all of this.
Okay, thank you. So we have at least these topics that we need to look into more deeply discussions. So let me close now with calling Natalie. Just because sometimes there is a kind of difficulty sometimes to go from the research to operationalization. So based on the experience that private sector has, what are challenges you encounter integrating this within your discussions with the public authorities? I mean, how is your experience on that perspective to go from research to operationalization, and then try this discussion with the public authorities? Because we saw from the statistics that Francesca showed before, is this service is going to be for the public domain. So which will be the challenges that you have as a private sector here?
Okay. Most of I'm speaking for the compliance market, so the LULUCF inventory. Most inventories are based on statistics at national level, and there is a certain reluctance also we can see with authorities to change methodology and also integrate Earth observation without assessing the uncertainty. This is for sure. I think it's different also with the availability of data For the Breathe project, we also work with Austria, which has already a very good NFI inventory with a 4-kilometer grid sample based NFI, and also already tier 3 approach. And I think the context is different in Turkey, where they lack biomass data, and their Earth observation can play a role in providing some kind of proxy. I think this is why for Turkey, it's also a bit different, because Tuvil actually contributed to another project in Turkey to implement the first EO-based LULUCF MRV service based on Landsat, so from the 1990s to 2015. So they were one of the first country in the EA member states to integrate Earth observation. So I think they have an opening towards these methodologies. And now with this Breathe project focusing on the forest category, they will at least use it for verification purposes. So yes, but then we have developed like a pre-operational solution, which is scalable, but there are some steps to our operationalization, I would say, is yes, the willingness also from a political side to also use these advanced technology monitoring technologies, a change in the methods, which is not always easy.
Indeed. Thank you, Natalie. This is also sometimes a message that we need to pass, that should be different. There is a lot of innovation, a lot of research, how to operationalize that. And let me now just call also again.
Monica, sorry, can I just add a little bit to what Natalie just said?
Oh, yeah, yes, please.
Yeah, it's not just a question of uncertainty. It's also a question. One of the very important IPCC reporting principles is that we are able to guarantee consistency across the time series. And in this area where the products are very exciting, but they are constantly changing, this question of time series consistency is a challenge in itself, because if I use a biomass density map that changes every year, that becomes a problem from a reporting perspective. Not only the effort of adapting the methodology to a particular product that may be discontinued next year, and then adapting to a new product that may be discontinued next year. So there's also that challenge. It's not just, let's say, it's not just a mental resistance, which may exist. I'm not saying it doesn't exist, but it's not just a question of mental resistance. It's also a question of making the effort and then having the certainty that this product will be around for some years. Nothing lasts forever, of course, but we can't, most of us in the reporting community, we don't have the resources to constantly change to the next hype product that is much better than the first one. But then this level of change is a challenge in itself. I just wanted to make that extra comment.
Yeah. That's a great point that maybe we could expand on the breakout session too. They will be focused on this interaction. But let me now conclude a little bit on calling also someone from the audience is Sandra Molly from Ballon Technology, another EO service provider. But they are working more on the early wildfire detection. So from this perspective, the exercise presented today, how do you think this service could support the activities that you are doing? Or, I mean, you saw for first time, so but maybe taking a reflection if the innovation could also support a service provider to upscale services in the private sector domain.
Thank you, Monica. Yes, I'm Sandra. I'm from Malin Technology. And as you mentioned, we're a private company, but we provide EO services to a number of central government organizations. And one of these is mapping burn scar. And like Paolo, we kind of give a 0-1. There was a fire here, there wasn't. We haven't branched into the greenhouse gas emission calculations, and this has been really, really interesting. From our point of view, I guess, one of our main challenges is actually mapping correctly where fires happened. A lot of our fires are quite small. And also they happen in our forests. A lot of our forests are in upland areas, and we suffer a lot from cloud covering areas. You could wait several months before you get a really good view of some upland areas. So I guess we're kind of still at the stage where kind of accurately mapping where a fire has happened. Another challenge we've come across before as well is kind of sub-canopy fires, where when you're using optical imagery, you don't really pick up on them, but we've been told by inspectors that a fire did happen, but it was at a lower level.
Yeah, thank you very much. I think somehow we are keeping this wording just for reflection. Also, we will be splitting now soon, but just some remarks for reflection. The idea is that we need to better support the users. I mean, we are doing this for something. So the idea is really to look within your own perspectives from the different organizations how we absorb this uptake or adoption. So, and also looking into the long-term development within your current methodologies, but also with the new methodologies like Chiara presented. So this might be reflections from the breakout sessions. Thank you very much for all the panelists and also the external audience that has been asked to take the floor. So just for me, it's really a round of applause, a digital one probably.
As you know, we are approaching the end of the webinar, and you've been for a couple of minutes into these two breakout rooms. So I wanted to ask you both Chiara and Monica if you have any highlights from these breakout rooms or from the overall webinar that you want to showcase or to share with us before the final conclusion. Chiara, do you have any remarks from the breakout room sessions that we just did? Any questions that came out from your side or that you might want to, I don't know, improve or to add into your methodology?
Well, from the breakout session, we had two main questions. One related to how we calculated the combustion factor, and also how we have done it by vegetation class, so differentiating between different land cover class. And the other question was related to the resolution of the products that we use. So, for example, we have Korean land cover, the land class data that is about 100 meter resolution, but then the fire perimeters detected with Sentinel-2 could be up to 10 meters. So there are some information that get lost. So it's always about trying to improve this product. And that's always a challenge.
Thank you, Chiara. Indeed, absolutely. And again, we were the technical demo session, voila. So we were very technical questions. Monica, from your side, from the consultant side, so
yeah,
any key fires that you want to?
Yep. Thank you. Well, obviously, it's difficult because there is this consultation session is a little bit more generic. So there was the sentence that I like it about not reinventing the wheel. There are many stakeholders doing similar things. So let's try to approach. The way to approach this is the difficult one. Is the 1 million question that Paolo indicated. So it's really difficult, but we need to be there. We need to be consistent on the discussions. There were also some questions about particular matter that also Statistical Canada was indicating. So maybe there will be a bilateral discussions going on. And maybe Chiara, we will put you on the loop on this. And then this reverse modeling is also important, that see also how ENC and WF is also improving the methodology with all the discussions. I mean, I take a lot of notes. All these notes will be available to all the participants, but I think we need to move forward because we are 7 minutes before the ending of this. Okay, thank you.
Thank you very much, Monica. Indeed, how do we do this? So we are approaching the conclusion of the webinar. So I see that many people already left, but that's fine. I will ask you still your time to fill in 3 questions. And while you will be doing it, I will be explaining you why. So can you see my screen with the Menti?
Yes, we can see it.
Can see you can see it perfect. So if you can just reuse the QR, or maybe you're already there. So there was a question about would this tool be useful for your organization? So it was previous, let's say. I know that some of you already replied, but maybe not all of you. So maybe after this very good panel and breakout rooms, maybe we can have some more yes eventually. I can see that. That's good. Okay, something more interesting. That's good. What's the purpose now of these questions? As I was mentioning before, these user uptake webinars and the discussions with you and the communities of users is really to make sure that we get in touch with relevant stakeholders and communities that could benefit or could make use of the pilot that Chiara just presented. And here, in fact, since it's a modular approach, here we enter indeed the last phase. It's the exploitation mode as well, right? So would this pilot, would these solutions be useful for you in the future? And would you like to eventually either test it again as a test validation user? And I think that indeed this is my further questions. If you would like eventually to be a validation user as well of this pilot, why this? Because after the user uptake webinars, it's not that we are done. The pilot is not going to be developed anymore, but there will still be some implementations that this pilot will be able to do to better implement. I don't know, either the user experience or some data. So this could also be your chance, for example, to just test it again, and then get in touch with me and Chiara to discuss it a little bit with more details, and then we will try to see if we can indeed integrate all of this. So I can see there are some of you are yes, 5. Okay, yes, that's really good. And then the last questions that it's a little bit more open is what kind of further challenges as well would you see by using the service, both from a methodology or a tool or a platform point of view. So maybe this I will leave it a little bit more open because it can take a lot of some more time. But I think that with Monica we already managed to gather a lot of the challenges of what could be, of what this could be. So calibration indeed of the various data sources is indeed one. And indeed all of this for us is very important because then we could envisage eventually further discussions or bilaterals with some of you to understand indeed how you can eventually become either an exploitation user or a test validation users. So with this, I think that it's already giving us a lot of details. Monica, do you also have any comments that you want to bring in by seeing these challenges, or any other final points that we want to showcase?
Yeah, no, I think they are quite consistent with some of the key messages that the panel already mentioned, and also probably in the breakout session. So I think we need to take this forward. It's just yeah.
I agree indeed. And I will conclude then by saying that the next step forward indeed will be a feedback form that you will receive by email to really ask you concretely if we can contact you, and if you're available to either become a test validation user or an exploitation user. So in this way you have some time to rest and see everything that we've been talking. So with
the form is already in the chat, so you can already follow up right after this webinar.
That's great. So indeed, either by chat now or also by through the thank you email, you will also receive it. Thank you very much, Lorena. So from my notes, I think I've said everything, Monica. So I think then I will close the webinar. Maybe no, actually not. The last news is that indeed, if you want, you can join us next month on the 27th of February for the final webinar. That it's going to be. Okay, that is going to be on the 27th of February on Zoom about Pilot 3, which is about acidification and eutrophication and acidification. So we are going to reconnect again with the community of users for this thematic and retest again the platform and further continue the discussions.
Thank you, Francesca. Just to remind that this is a modular approach. You saw an algorithm, a methodology, data sets that are coming into that, different tools, and a platform. So everything is a modular. So depending on the user, you will need some things or others. This is the discussions that we would like to take forward with you. Obviously, replying to us on which is the component that you are more interested to be for your workflows or activities. So thank you very much, Francesca. So my side was only to remind this modular approach. The floor back to you.
Very important. Absolutely. And again, thank you very much for your very active participations. And we will get in touch with you for a thank you email, the feedback form, and also the final, let's say, key highlights of our conversation. So again, I wish you a very good afternoon, and I will see you very soon. Bye-bye.